Hello class, this is a video tutorial on differential equations part 2. In this video, we'll be looking at solving differential equations. To solve differential equations, we treat and manipulate dy and dx like variables, and we apply integration methods. Depending on how much information is provided, the answer to differential equations can be made more accurate. This is referring to plus c, and note, and you'll see this in the examples, where the plus c is placed is arbitrary, meaning you can place it nearly anywhere, as it will give an equivalent value when you solve it depending on where it's placed. I'll demonstrate this in the following examples. We have 6 examples that we'll do, broken up into various videos. And you can pause and give this a go yourself. Let's get straight into our first example here. All right, so for this, we take our differential equation, and I'm going to show in tedious step every single step of the way. So for this, we multiply by dx on both sides, giving us dy equals 6x squared minus 4x plus 3 dx. And this is thought of like this. It's because normally, if we were to multiply it, the dx would be distributed to every single term like this. So it's 6x squared dx minus 4x dx plus 3 dx. But to keep things nice and simple, we treat it like this. Then from here, we integrate both sides with respect to whatever the dx is. Now remember, this is treated as 1 dy. So now when we integrate this, the integral of 1 dy is just y on its own, and we integrate this as normal. So this becomes x cubed minus x squared divided by that plus 3x. Now here's what I mean about placing plus c arbitrarily. When we integrate this, we could have plus c here, or plus c here, or you could have one and the other. So you could have a different c for each one. But now consider that this is a integer or a whole number, and this is another integer and a whole number. If we were to move plus c1 to the other side, we would get minus c1. These two are whole numbers, okay? Well, if they're whole numbers, we can still treat them as one integer. Okay, so for this, to keep things simple, we always put the plus c where the dx is. So this is a solution to the differential equation. But now, because we are given more information, we can specify what c is. And we've seen this before. We just substitute the values of 5 for y and 1 for x. And this will give us c. So we get 5 equals, substituting 1, that becomes 1 times 2, minus, substituting 1, that's minus 2, plus 3, plus c. We get 5 equals 3 plus c, which means c is equal to 2. So our more accurate result is 2x cubed minus 2x squared plus 3x plus 2. There we have it. Now let's just say this is just for demonstration now. Let's say that we place c on the y side instead. So we get y plus c equals all of this. I'm going to erase that plus c in a moment. Oops. So let's just say that we put the plus c on this side instead. Let's take a look at what happens when we substitute the same values. So we get 5 plus c equals, and substituting 1 again. So 2 minus 2 plus 3. Solving for this, we get 5 plus c equals 3. And we get c equals negative 2. So if we put plus c on this side, we get y minus 2 equals this. Do you notice how now, if we move this across to the other side, we would still get the exact same result? Okay, so that is what is meant by this one. Okay, so that's just the first example. Hope that gave you an insight into solving differential equations. You've probably noticed by now that it's the same as integration, but we're going to go in a deeper manner for this. So hope to see you in the next video, and best of luck.